welcome to Dimension Data, the first session which is preparing for a wireless future. And I suppose to get started, we still need to start looking at some of the facts associated with the wireless future and how it's going to impact on our businesses. And so if you look at the facts, at the moment, roughly there's about 1.5 wireless devices to every person. So roughly we're talking internet connected, maybe around 10 billion wireless devices. By 2020, they expect that to blow out to about 8 devices per person. If you think about that, that's your laptop, that's your iPad, it's your Android device, it's your Fitbit device. In my case, in my lab at home, it's my wireless remote control for all the devices that sit in my lab. So I may be up to 5 devices myself already. So I think that's reachable. By 2020, that number is going to increase to, it's estimated, 50 billion devices. But of course, research tells us that only 7% of those are going to be cellular equipped. So the remainder of those wireless devices are going to be wireless or Bluetooth or whatever the prevailing technology is at that point in our environments. And most of those connections are going to be machine to machine, which is interesting in itself. If we go then to what are the wireless applications that are going to affect our future? Well, I've categorized them into retail, industrial, medical, education, corporate, service providers, and Internet of Things. So let's go have a look at the first category along the way here, and that is retail. Retailers already spend a lot of their time and money monitoring what goes on in their stores. So they use technologies like video, and they're already tracking you by, for instance, your MAC address. And what they're interested in is they're interested in how you're using their stores. And they want to engage you. And if they can engage you with the use of applications, then they can map together how you use. And of course, an important part to a retailer, of course, is the concept of location. So in the future, if they can identify you, identify your purchasing habits and your location within the store, they can use video banners or screens on the side of the aisles to identify potentially what you're interested in. And also they can use pop-ups on your phones maybe to remind you through the app, that you need to buy, certain elements. Interestingly enough, the research for retailing tells us that we're now combining both online and in-store shopping at the same time. So they want to encourage you to use your phones, of course, nowadays in the store and to make their store more attractable than another. All right, sorry. Okay, in the industrial environment, RFID tags have been around for a while. They've been used to monitor, for instance, manufacturing. So we can use RFID tags or wireless sensors in the form of identifying the device and proximity, and of course, asset tracking in those environments. In some of the more hazardous environments, the RFID tags are used for personal alarm systems and for staff location. So you can tell if you're on Ulrich, for instance, where your staff are at any given time. Also telemetry. What's interesting is Cisco and Honeywell have actually teamed up, and they have the Honeywell One Wireless system. And the One Wireless system is actually built on top of Cisco Mesh Wireless Networking, but with Honeywell radios built into them. So the Honeywell radios allow for NC control, but they also allow for telemetry and collecting information within the factory. So we're seeing a growth there. Medical. In the hospitals, they probably have some of the largest and most dense AP networks. They've been using telephony for a long time, so they're quite experienced with it. There are now, of course, patient recording systems, or web-based and wireless-based, and the use of Vocera badges for distress alarms and for emergency paging is very popular. Equipment, so some of the equipment, to find it, you can use our RFID tags on that equipment, so it might be a $200,000 piece of equipment. We can find it in the storeroom versus in the cleaner's cabinet versus the storeroom where it should be with RFID tags. And proximity alarms. So RFID tags are used for proximity in aged care. So in an aged care centre, if I have somebody who has, say, for instance, dementia, I can use a proximity alarm to identify when they move away from a given point. And when they move away from that point, I can raise an alarm. In the newborn area or in the infant area, there's a group called Stanley Healthcare who have a product called Hugs. So the concept with Hugs is you can put an RFID tag on the mother and on the child, and we can use that. So there are certain hospital instances where this is actually quite useful, and one is presenting the wrong child to the parent, to the mother. So if you take the wrong child out of the infant ward and pass it to the wrong mother, an alarm will go off. And the second is the problem that we have with people taking babies or abducting babies. Now, one of the problems that hospitals have is that you can allow family into the infant ward so they can view the baby, etc., but they have the added problem of is often it's the family that are the baby abductors. And so what the Hug system also gives you is the ability to identify the fact that the child has been removed from the container they're in, and when that happens without the appropriate process, or what you can do is you can trigger A, an alarm, and B, lock the door. So it's a great way of making sure that we have a secure environment for the newborns in the hospital environments. Of course, in the wireless world, we can use wireless apps to provide, or improve inpatient hospital experience by giving them things like menu selection, television selection, through a wireless app. The medical environments also present problems. So they actually, the medical environment presents quite a lot of problems. Number one is that the teaching hospitals, they have environments like lecture theatres that have very dense numbers of users that will require wireless in those environments, and that's a challenge to provide the throughput in those environments. And secondly, the hospital environment is there's a lot of sources of interference with microwaves and other. And so what we want to be able to do is, in a large hospital environment, identify interference easily on a map, for instance, and then we can go and do with that interference. So potentially it might be moving the AP or moving the access point to another channel. So, and lastly, in the hospitals, they have to deal with very old wireless technologies. And one of the problems is to get a piece of technology approved by the FDA, it has to go through a given process. So what the hospitals have is a lot of new equipment, but with old wireless technologies in them. And they do need to be able to identify those devices and potentially, encourage the manufacturers, maybe in the next round, to improve those technologies. Education in the school system, wireless is used extensively. Pretty much all state governments, at least in Australia, provide wireless networks and provide wireless tablets for the students, and that's a given. But in the school areas nowadays is that, to manage some children in the playground, for instance, or outside, is that you can use video and video over wireless in order to monitor what's going on within the playground. And maybe that gives the school the ability to say, excuse me, madam, but look, here's an image of your child being the bully in the classroom. We need to address this, and you need to address it at home. And lastly, on the bottom, the same video system, which monitors during the day, can be used to monitor the school at night. So at least we can get some footage of those people who are, vandalising the school, and maybe we can address it. In higher education, again, like the universities, extensive wireless networks already, and with Gen Mobile or the new groups moving into the universities, they're bringing with them 2 or 3 wireless devices with them, And on top of that, then, the university needs to be able to identify who the user is, who the device is or what the device is, and then based on that, provide authorization for them in the network. So we can differentiate lecture from students. Significantly, security is an important part of it. So wireless IDS and IDS itself to secure the campus network. And of course, with the universities nowadays, because of a lot of cross-campus travel, we need to provide a central authorization, a mechanism, for those universities. So if I am a university at A and I do go and take a lecture, I can log into the wireless network at University B and get access to my slides, for instance. And lastly, down the bottom, campus security. So, the diagram shows an example of, campus security where, in the car parks of the university nowadays, where it's expensive to implement, security cameras, I can very quickly, or we can very quickly build a wireless mesh network and then provide for monitoring of those car parks at night and during the day. In the corporate environment, our challenges, of course, are many. We have a steady growth of wireless devices, and wireless-only devices in that environment. And one of the strange things I've found is in our environment is that we're now releasing laptops to our staff, and they actually come instead of with a wireless dongle, they come with a wired dongle. So the staff comes in, and instead of plugging into the wired network and having the benefit of the throughput, they're now using the wireless network, and of course, and challenging us as into provide a wireless network that's capable of carrying all their traffic. Other things that we're seeing now, wireless printers, video monitoring, and Miracast for overhead projectors, and a range of wireless devices. And of course, with that, the corporate needs to identify the device, the user, and potentially the combination of the user and that device. So as an example, a corporate user on a corporate device, which I can do all the antivirus, etc. on, I'm going to give them full access to my network. But a corporate user on a non-corporate device, I'm going to give them restricted access. So that's what we're targeting. So in the instance of a corporate, can I just do a quick poll? I'm just interested in how many of you believe that using a wireless device improves your efficiency as an employee. So if I can just get you to raise your hand, that would be a good thing. So how many of you believe that using a wireless improves your...
Probably worth pointing out there's a little hand symbol that people can click on just in the panel on the right of the screen.
Thank you. Okay. All right, I'm not hearing anything from our panelists, so I can't see those numbers.
About 25% to 30%, I would say, of people have raised their hand.
Yeah, okay. From what I can see, most have raised their hand. So let's just go and have a quick look. There is, my apologies. Okay, so I just want to also just a couple of quick points as well. As in the corporate environment, we are now offloading our mobile phone data onto that corporate network. So all of you that are using those wireless devices, that traffic, it's actually controlled by an algorithm on your mobile phone. That when you connect to your corporate wireless network or a wireless network, automatically the data is pushed over that wireless connection. And that's also helpful in venues like stadiums, etc., when there's dense numbers of users because you want to free up that network space. All right. There's some surveys being done, and the surveys actually, or this is surveys of what people believe about, mobile telephony. In fact, the use of mobile devices. And so the EIU did a survey about employee experience with the use of mobile telephony. They actually came out with these points: is that that to improve they'll contribute more if they can work from anywhere at any time using a mobile device. Yeah, it gives them the ability to access information quickly and easily, allows them to collaborate effectively, and allows them to work from anywhere within the office space, and allows them to concentrate or more focus on work. So that's interesting. They also did a study of what's known as a mobile generation. So mobile generation are the group post about 1995. So they're the ones that are entering the workforce now that we need to cater for, and we do need to keep that in mind when we're catering for them. 30% of that group, as respondents, wouldn't work for companies. It wouldn't allow them to bring their own mobile devices. 49% believe that the remote flexible working was responsible for making them more productive. So that's interesting too. And of the companies that they worked for, 31% of the companies surveyed used mobile communication apps to improve the employee effectiveness. And I say for myself that, yeah, that's the case. Access to email, for instance, on my mobile phone is used to make me more efficient and work elsewhere. In the service provider space, it's really interesting. Wireless access is all about building loyalty and locking your users in. So providing Wi-Fi anywhere as a service to your customer is now a target for in that environment. And I'll give you an example. Telstra and iiNet are both investing in this, in Hotspot 2.0 technology. In the case of iiNet, in most of the major cities, they're actually implementing wireless networks. So that I can, if I'm an iiNet user, or in fact, if I'm any user, I can go and join their wireless network and get access, to the internet for a given period of time. Telstra, on the other hand, have a product called Telstra Air. And Telstra Air, again, Hotspot 2 technology, Wi-Fi technology, allows your Telstra customers to get access to the wireless network. But interestingly enough, Telstra have built an association with a worldwide wireless provider called FON. And so as a Telstra Air customer, not only does it work in Australia, but it will also work when I'm traveling overseas. And so I can use that to communicate with, say, my family, etc., over wireless rather than through a telephony connection. The Internet of Things, I think we've probably all heard about the Internet of Things, but they're all those wireless devices that are now part of our life. The wireless printer, the media player, the car connection, if you're lucky to have that, the Chromecast, for instance. And in the future, I like the clothes dryer. I like the clothes dryer that tells me that when my shirts are dry, I can pull them out before they get wrinkled. I think that's great. And of course, my watches. I've got a note down here just saying, be aware that with the Internet of Things, some of these devices and some of the applications are actually time critical. So it's pointless if I'm moving through a factory, moving through a store, and you're going to display something to me which is appropriate to me only if it's displayed once I've gone past that point. So keep an eye, keep that in mind. All right, Wi-Fi communication. If we start talking about it now, Wi-Fi communication. That communication itself, it's half duplex. So that means that you can only commute one way at a time, and it's acknowledged. So when you send a frame, you get an acknowledgement back. So that means that only one person can talk at once, at least maybe at the moment. Clients discover that the network, by sending probe requests, and the APs will reply with probe replies. This is going on all the time. So as you're sitting there, that phone is sending a probe request. It's looking for a better access to connect to. And one of the attractive things about this is that we can use that to track your location as you move through our environment. Yeah, Wi-Fi is cellular, so you move from cell to cell. Proximity to the access point is important because that will affect the speed of your connection. But also, connection does correlate to throughput, but it's not the same. So, if I'm connected at 150 megabits per second, the reality is that my throughput is, with overheads, etc., is roughly half that. And also, wireless is a shared medium. So when we're designing our wireless networks, if I've got 10 clients connected to an access point, and they're all connected 50 megabit per second, is that they're going to get 5 megabit per second, say, each. So they're sharing the access points. So not enough access points means potentially low amounts of bandwidth available for you. And I probably should say lastly, is that old clients slow down new clients. So if I have to communicate and there's an old client in the network, then I actually have to send the start of my frames at slower speeds. Yeah, and our broadcasts have to happen at slower speeds. So what does that mean to me? Well, at home, throw out the old devices. Don't have them running, don't have them wirelessly connected. At work, set up mechanisms by which you can remove those devices from your network. Don't encourage the use of old devices, if you can help it. All right, so wireless clients connect at two main frequencies. So I suppose let's kind of have a quick look at some of the technologies that are used. And I like this statement. To build better solutions, we must understand the needs and we must embrace the technologies. Okay, so the first, type of wireless information I suppose we need to understand is how do they run? And they run actually on two key spectrums. The 2.4 gig spectrum. So this is the spectrum that most wireless devices are connected at. It's the busiest spectrum because of that, but it also provides large coverage areas and has very good penetration. So I can have my AP at the front or in one part of the building, and through the walls I can pick up that signal. As the most crowded spectrum, it's also crowded by non-wireless devices, baby monitors, Bluetooth devices, decked phones in the corporate world. So those devices, suppose it's not that new, but 802.11ac operates in the 5 gig spectrum, and we're going to see top speeds of around 3.47 gigabit per second. So it's actually quite fast. IEEE theoretically suggests it will be up around 6 gig. So let's just say 3 gigabit per second. Maybe that might give me a throughput on my connection of, say, 2 gigabit. It's becoming standard for all access points that support, both 2.4 and 5 gig, and rolled out in 2 waves. So there was wave 1 and wave 2. So now the new devices are the wave 2. These are the ones that, we want to put into place now, or we want to upgrade our older APs too. There's a couple of reasons for that. Is that they provide denser modulation, so you can carry more information on the wireless signal. They use bonded channels. So instead of a freeway that is, 22 megahertz wide, like one lane, I now have a freeway that is, up to 8 lanes wide, and so I can carry more data on my connection. They also have some neat tools to do with antennas or spatial streams, and the concept is this. If I send a wave, from one antenna, so say I'm standing on the beach and there's an antenna out there and it sends a wave, yeah, and every 10 seconds I get a wave, is that with multiple antennas, I can slip waves in from each antenna between the original waves, and so I can send more information. And now, as an option as 802.11ac wave 2, we can do multi-user, multi-in-out, which means effectively is that, each of those waves is carrying individual user information. And so I see it as my access points now are going to become more like a switch rather than a hub, which can deal with only, one piece of information a given period of time. Okay, so technologies that we're starting to see, Bluetooth, yeah. I probably should ask this question, how many of you have Bluetooth devices and you use Bluetooth devices in your home in particular? So yeah, well, I know you have Bluetooth on your phone, but how many of you have Bluetooth devices in your home that you're using them and you're using them now? So I get you to raise your hand if that's possible. Yeah, so if I'm scrolling through the participants, I'm seeing almost everybody, which is a bit surprising, or I find that surprising, is that we're using Bluetooth, or that we are using Bluetooth. And so let's have a look at some of that Bluetooth, why we're using it, what's attractive about it, and why it potentially could be could it be problematic in our wireless world? So first up, let's have a look at it. First up, Bluetooth operates on the 2.4 gigahertz free wireless spectrum. So it's already on the same, can affect my 2.4 gig data devices, all right? But it uses frequency hopping, which basically means it then spends small amounts of time on a given frequency and then hops to another frequency. So you end up with a little bit of a speckled pattern, as you can see actually on that screen there. I've got here small amounts of data, but of course now we're using Bluetooth for streaming, residential, of course, and in-car technologies. And the note here is it's not compatible with your Wi-Fi solutions. So when we have Bluetooth devices, you know, they're seen as noise or interference by your wireless devices, and that can impact on the performance of those devices. So it would be nice to be able to identify those devices somehow and maybe avoid them if possible. All right. Of the Bluetooth technologies then, this little guy is gaining a lot of ground, particularly in the retail environments, but it's moving into all environments, I have to say that. It's Bluetooth 4.0, and it's known as BLE. Apple market as iBeacon, Android Eddystone, or Google Eddystone, Google Beacon, Samsung Beacon. They all have a product that works in this area. And I'll read from the quote from Wikipedia that helps to describe, you know, how it is, and it applies to all of these beaconing BLE technologies. As a class of Bluetooth low energy devices that broadcast their identifier to nearby portable devices. So they're sending beacons out regularly, and the technology enables smartphones, tablets, and other devices to perform actions when in close proximity to an iBeacon. So it can trigger an action or trigger an application. So for instance, if I move into a store and I move towards a given, you know, rack of clothing, that BLE beacon device will trigger my phone to being connected to the network to actually say, okay, gee, here's a special on this rack. You know, you should buy it now. By the way, you bought 2 of these last week, and so we think you need a 3rd one. All right, so campus maps, in-store information, push applications is where Bluetooth low energy is going to be seen. And if you're real keen, check out Roximity.com. So there's some great examples there of technology that they're actually selling now. All right, because of, you know, the non-wireless devices in our spectrum that are starting to help us, they're starting to occur, or also because, let's say for instance, I've got a Bluetooth application, Bluetooth LE application, and it's not working so well. How do I identify what's going on in my environment? And so historically what you would do is you would log in a spectrum analyzer and you would start looking at these past Fourier transforms with a view to try to identify what the interferer is. And so with spectrum analysis, you know, that's what we're doing. We're looking at these charts, we're trying to identify them. So that's great, but I really want to automate that process. So both Cisco and Avaya provide now spectrum analysis or spectrum analyzers built into their wireless APs. So how does that help me? Well, they're sitting there, they're monitoring the wireless spectrum, and they're identifying the devices that are existing there that are non-wireless. And then they're going to trigger an event. It could be an alarm for me, but it could be a radio resource management event. It might be that it's identified that that DEC phone is sitting on channel 1. Maybe we should move our access point channel over to maybe channel 6 or 11. So, you know, that can be done automatically for me nowadays, and it's a great thing to look for. Cisco, of course, high-end access points, Aruba, you know, it's a license. Cisco have a wonderful feature, and most providers have it, that'll identify the zone of impact. So I can go to a map and I can see the device is causing interference, and I can see the area that it's interfering on. And so, you know, I'm better serviced myself. And so it leads me to the management technology. So when we have this information, how is it being managed? Well, the access points themselves, historically been managed different ways. The first is as an autonomous device. So the autonomous device, it's got a command line or web interface. You jump on and you configure it. Yeah, then you go to the next one and so on and so forth. Yeah. So we went from autonomous and we actually, there was a company called Aerohive. And Aerohive still exists. They came with a concept called cooperative control. And their idea was this: would it be great if the APs could talk to each other and then decide what power levels, channels they were on, and move to those? And so that's what they came up with. And surprisingly, Cisco have introduced this behavior into their access points. So if you have a Cisco 1800 series access point, say an 1850, is that you can enable mobility access, and so hence you don't need any sort of centralized control. The APs themselves will manage the wireless environment. So we're moving towards that. So if you've got a small site out there, that's a nice way of, instead of having, autonomous devices out there, is to use potentially, this cooperative control. And last, of course, and probably the most common in the corporate world, is the centralized control. And in the centralized control, we have, I like to refer to as private cloud. So I have a controller. The controller talks to the APs, collects information, processes it, and then with radio resource management, tells the APs what power levels, what channels they should be on. Yeah, and potentially might encourage your clients to move to another AP who's loaded. So that's private cloud. If we go to cloud-based, so Meraki, Aerohive, Aruba, all provide cloud-based solutions. So we move that out of your environment and into the cloud. And of course, the nice thing about having either of the cloud-based solutions or control-based solutions is that we can, at that point, we can implement reporting, wireless IDS, and other, antivirus technologies. Majority of the technology that exists is in those environments is CAPWAP. CAPWAP's an acronym for Configuring and Provisioning Wireless Access Point Protocol. And it's all about a splitting of the roles performed by an autonomous access point. So what they've done is they've taken an autonomous AP and they've said, we're going to have an access point that performs certain roles, and we're going to offload some of the jobs that access point does to a controller. And so access point looks after encryption, decryption, beaconing, encapsulation of traffic up to the controller, and scheduling of packets, and the controller itself is responsible for association of the client, the authentication of those clients against the radio server, the mapping of that traffic onto a VLAN, and of course access control and authorization at that point. So that's where potentially maybe your traffic has an access list applied, which restricts what we can do here. And of course, the controller, or that centralized point of control, is a key to managing your encryption keying and aiding you with roaming. All right. So the challenge then of roaming across your environment is to maintain the connection and roaming securely. So with the centralized controllers, what we can do is given we have the keying material, because we spoke to the radio server, we can pass that keying material down to the access points as you move through those access points, as you walk through your campus environment, or from floor to floor. With the challenges of roaming, I suppose from my perspective, is that now what we're dealing with is new roaming technologies where they were once proprietary and required proprietary drivers like Cisco CCX. Now 802.11r introduces a concept called fast transition. So it's a standard mechanism for doing roaming, and it uses over the air and over the distribution system that you're attached to pass keying material on to the next device. So from my perspective is that if you're looking to buy wireless equipment in the future, it really should support 802.11r. So, ask the question of your vendor, do they do that? But be aware that enabling 802.11r might preclude some earlier clients from potentially joining your network. If they're roaming through the network, often we still want to identify where they are, so wireless location technologies are used. Historically, it's been based on signal strength. So, the closest I are to a given AP, that's a good way of identifying where I am. And if I can be seen by multiple APs, then with triangulation, I can predict where that person is. And so that's what we've used in the wireless world. Angle of arrival is a curiosity. It's used by aircraft. So, if I have multiple of those spinning radar systems in my environment, and I've got an incoming plane, I can use the angle of the signal to work out where that plane is. So, between those two locations. So angle of arrival already used. Time difference in arrival is used by GPS systems to aid by sending a beacon, and the satellites identifying how long it took, they can work out where you are. And the last is are exciters, and of course BLE beacons and sensors. But the concept of an exciter is as you move through a doorway, for instance, if you've got an RFID tag on you, then as you move through the doorway, the exciter triggers the tag to send a beacon frame. And from the perspective is that we now know the device has entered that space. Yeah. So there's no illusion to whether it's in room A or room B. We know it actually has entered that space. So exciters are used quite extensively in a lot of environments for just that reason. I probably should say there's no best solution, but best of purpose here. And I also will say that, in the future, we're seeing a combination of these technologies used. And what I've thrown in there is a picture of a Cisco Halo AP. And the Halo AP has a ring of antennas. So I think it's some 32 antennas, if I'm correct. And so what we can do is, of course, we can do receive signal strength, but we can do angle of arrival. And in the case of the Halo devices, we can also do BLE. And so we can use Bluetooth, we can use wireless signals to identify where the devices are. And Cisco are now claiming that technology will get them down to within, a meter of where that device is in real time. Yeah. So I think, these are the technologies that in the future that we'll use. So I would be looking for, does my AP do this in the future? Are they building this capability into the APs, or will they support it? The slide's in there just as a reminder more than anything, is that your wireless infrastructure is dependent on a wired infrastructure, so it needs to be right. It's also the point where your wireless data is aggregated, so we need to have high bandwidth connections on the devices. So if they're controllers that we're using, in the future we'll need 10 gigabit interfaces plus. Also want to introduce the concept of zero touch, and I think Cisco provided a feature called Cisco Smart Ports, where you can plug a device in and it'll configure the port based on the type of device. And I find that great because I can give that electrician that AP, get him to plug it into the port, and the smart port will actually configure the port for me, appropriately for that access point with trunking, etc. Which I think is great. So it's going to minimize my infrastructure work that I need to do. Other things I'm looking for, of course, in my wide infrastructure is statistics like NetFlow. I need QoS and some other tools like event scripting and alerting, which will allow me to trigger events or know more about what's going on in my infrastructure. Of course, security and provisioning. Now we have, with Internet of Things, a much broader attack surface. So we now need to, be aware that with Internet of Things, people do have devices that they operate in the work environment, but they take out and they operate it in unprotected, more vulnerable environments like coffee shops, etc. So I do need to be able to, when they bring them back into my environment, I do need to be able to identify not only the user, but the device, and then I can provide access control to it. And one of the important parts of that recognition is an MDM solution, or mobile device management solution. What I want to be able to do is use an MDM solution because it's going to give me a couple of things. Better granularity and identification of those devices, but also policy management for those devices. And as an example, if I'm going to let you use your wireless device or your wireless phone and run a corporate app on it, when it gets lost, it's lost with that corporate app on it. So I want to use my MDM solution to remotely wipe that device. So I want a policy that will enable me to do that. So that's what I'm looking for. Patch management is, of course, important, anti-malware. But also I've got a note in here, keeping the clients up to date is important. Because if I can keep the clients up to date, I can get the same level of encryption with shorter keys. So with the new technology, that's a great thing. So it's going to, by using the latest of technologies, at least encryption technologies, same encryption strength, less overhead and less memory required to run those algorithms. And that's an attractive thing as part of my security solution. Wireless intrusion, I'll just say that, it makes sense to be able to detect wireless events and to be able to take action to them. So reconnaissance is one, denial of service, yes. And I've thrown in here the concept of rogue and ad hoc devices, not necessarily around my network, but within my network. So if I have, for instance, my manager who brings in his own AP, plugs it in, and then connects to it, is that I want to be able to identify that. I potentially want to be able to contain that device so that he can't use it. And then I'm going to go and I'm going to remove it from the system. So, that's the kind of wireless intrusion things that I'm looking for. And then, of course, management. I want all this information to arrive in a management interface, and then I want to have that management interface provide me with centralized management for the features of my wireless access points and my wired devices, alerting and reporting. I want to be able to report on those old wireless devices that are living in my environment so I can remove them. Also want my system to be able to correlate information. So collect all the radio-based information presented to me, but also collect wireless intrusion information or location information and correlate it and present it to me in a more meaningful fashion so that I can use it and or pass that on to others. And while I'm there, I want that system to be able to allow me to script a trigger. So I want to be able to trigger or script triggers and know when a given event occurs, when a particular device has been removed, for instance, from the environment. I want to know, and I want to be given an alarm. So that's what I want out of my management interface. All right, as part of that, analytics is going to be a key part. So analytics is going to allow me to start looking at common paths or identify, say, for instance, in a supermarket, what the common path is people travel through that supermarket. And if that's the case, maybe I'm going to charge the products that are on that common path, the people who provide them to me, a little bit more for having that benefit. It also allows me to get best bang for my dollar. So I can place, for instance, say a web kiosk at the appropriate location rather than where I think the appropriate location is where it's going to be used. So analytics is going to be a big part of monitoring, managing in the future. So I think we need to embrace analytics in a big way. When we start talking about wireless, now we need to start talking about the distractors. And so what are they? So we're going to be operating with, say, for instance, 802.11n 2.4 gig devices, 802.11ac devices, and BLE, but potentially what are the distractors? So this is the first one that I think is going to be a big distractor. It's from the Wi-Fi Alliance, and they do WPA. So these guys, know what they're talking about, and they do the hotspot technology. So the Wi-Fi Alliance are now pushing for a new product, and it's based on 802.11h, and it's known as Halo, and it's a low-range, low-power wireless solution. It's going to operate in the 900 megahertz band, and it's going to use effectively the same wireless technologies. So the ramp up for vendors should be reasonably quick. So mass mass market adoption should be quick too. So it potentially is going to provide better connectivity for our Internet of Things than Bluetooth will. And so I think that's going to be a potential distractor in the future. So maybe the biggest issue we all have is that Bluetooth or BLE is already established, and then maybe it won't have the inroads that I think it may have. The second distractor, and it is LTE over the unlicensed spectrum. So Ericsson, Qualcomm are now demonstrating the operation of LTE technology or mobile phone technology in the 5 gigahertz space. So before we start jumping up and down saying, oh, this is good, those devices will still need to have the same footprint as your wireless devices. So if you need a wireless access point every 10 meters, you're going to need an LTE-U device every 10 meters. So that might put a stomp on them being in your corporate environment, but maybe large stadiums, it might have an inroads. Coexistence with our existing 5 gigahertz devices is going to be a problem. So if they're using it and they're not using wireless frames, then we won't know, and we'll just see them as interferers. And so actually, I do have to say is that the LTE consortium and the Wi-Fi groups are now trying to work to get these two technologies to work together. But keep an eye on this space. I think it's potentially going to be a big growth area. And Cisco have bought in with a group called SpiderCloud, and they're already in a process of building LTE-U modules for the 36-3700 APs. All right. So here are my tips. Start thinking about consolidating your wireless data, and we're looking for security and location information, at least at this point. Look for good solid analytics. So that's going to be part of our wireless installations in the future to help you guide the growth of those environments. Explore the vertical apps, and I mean that. So, if you have SAP, start looking at the SAP applications that you can use in store that will work with wireless. Yeah. Provide wireless to your customers, clients, and staff. Otherwise they'll go somewhere else. In reality, I can shop here, I can shop there, they've got wireless. I think I'm going to go there. Yeah. Monitor both your wired and wireless networks. That's obviously very important. And build a platform that allows you to customize your portals and encourages users to join your network easily. And I think that's going to be important, particularly in some of the larger hospital installations and retail installations. And lastly, provide incentives. So if I join your wireless network in the Apple Store, I want you to give me some sort of coupon, that rewards me from doing that. So I'll come back next time. All right. So if we're now looking at these technologies, I actually thought, my manager. So I sort of thought, okay, if you're looking, if you've got staff that you need to have trained, then, what do I need to know? And I'm just throwing up that Cisco have revamped their wireless courses with the new technologies in mind. So if I just flip through them, what are they? CCNA Wireless is a wonderful course called Wireless Fundamentals. And yeah, it covers the wireless technology right from ground up. So if you have no wireless exposure, then you can use it. But interestingly enough, it engages or uses the Cisco converged access series switches. So the newer switches that Cisco have in their environment that support iOS XE that can function as access points. Secondly, if we look at CCNP Wireless, then there's designing a wireless framework, site surveying, planning, and post deployment reviews of your site. So the second is wireless deploy. So let's get in and get it deployed. So what do I need to do in order at least to get Cisco network infrastructure up in place? And it's seeing QoS, multicast, and mesh a significant part of this, along with prime infrastructure as well. You're probably now sitting that there's no ICE in those but this is where the Cisco IC is actually pulled in. And so with Wireless Secure, we look at wireless security, how we can deploy it, how we can secure it, and how we can monitor it. And we use Identity Services Engine Release 2.2 in these courses, at least at the moment. And lastly, wireless troubleshooting. So if you have, if you're looking to round off your skills, then Wireless T-Shoot is all about identifying a lot of the common problems. So APs joining networks, the client connectivity issues, how to identify and locate your RF interferences, and troubleshooting client performance issues, which are probably some of the more difficult things to do. So we touch on those courses. So some great courses. Right, so I'm now going to open up for questions. So does anybody, I'll give you opportunity now to ask questions. So over to you guys.
Hi Rob, can you hear me?
Yes, I can, yes.
Fantastic. Well, thank you so much for a very informative session. We've got a few questions that have came through. And the first one is, so what if I'm new, or my team is actually new to wireless? Where do I start?
Okay. So if I was looking at developing those skills right from ground up, I would start with the Wireless Fundamentals course, because we start off with very base level. We look at the network infrastructure, so we look at autonomous and we look at controller-based and cooperative technology. We look at the wireless technologies, and we look at how they fit together. So somebody at that level at CCNA will get a touch on a good solid background in the wireless technologies, and they'll get to see how the elements put together a wireless network. So with wireless fundamentals, and then maybe look at moving your groups through the CCNP wireless program, or pick at the bits you particularly want to maybe touch on.
Great, thank you for that, Rob. The second question we have is it important to be using a VPNs like ExpressVPN when traveling and using Wi-Fi networks in hotels, airports, etc.? And what are the risks of not connecting or by using a VPN service?
Oh, okay, that's a good question. Is wireless does use encryption, but the wireless encryption is typically between yourself, the wireless access, and the wireless access point. So, even though I might be using technologies like, for instance, WPA encryption, that's between myself and the access point. Once the traffic leaves that point, it's no longer encrypted. So that means that anybody in that path could potentially get access to that traffic. So by using a VPN connection, I can ensure that the traffic is encrypted from my laptop through the wireless network, and then through the subsequent networks, to my corporate, say, head office or head-end VPN router. So yeah, it's important to actually make sure that we do that.
Great, thank you for that. Paul, I hope that answers your question. We have another question come through. So in case we have some interference with the 2.4 gigahertz, is it good to hard code on edge devices, for example, laptops, on that's possibility select 5 gigahertz only?
Oh, that's a good question, actually. And it depends on your network. So in the case of like a lot of corporate networks, for instance, they might reserve the 5 gig spectrum for voice and video. And so they might not particularly, want you on that wireless network. So that would be a good question to ask your internal IT staff. Do they want you to be able to use that? And I will give you an example, though, is that at the moment, our own data 2.4 gig spectrum is actually getting heavily utilized, and so we are looking at moving our users or making the 5 gig spectrum available for data clients. So if you're in an environment where you're having you're getting particularly bad performance out of the wireless network on the 2.4 gig spectrum, maybe maybe you could do that. You know, again, I would maybe talk to your internal ITS, make sure that's you know, they want you to be able to do that, and then, you know, yeah, hard code it and then move on to the 5 gig radio. But I'd check with where that would be, where they want you to be doing that. How's that?
Thanks for that, Rob. Paul, I hope that answers your question as well. I think we've got time for one more question here. And the question is, in terms of a wireless AP for home, what should I be looking for?
Actually, that's a great question. I think now seems to be the time to buy. There's a lot of new wireless technologies with 802.11ac coming out, and we have a lot of wireless devices in our network. So I would be looking for something that had 802.11ac on it. Wave 2 would be what you're looking for. And so that device is probably going to give me or extend the lifetime of my wireless access point, and it's going to typically give me better coverage and better throughput when I move to, you know, AC compatible devices in my network. So look out for that, 802.11ac, but be prepared to pay a little bit more for those access points, because they are going to be more expensive. And the same for the corporate world. You know, start looking at maybe, you know, phasing my APs over to 802.11ac, you know, technologies, or the newer technologies.